Welcome to GER Hub Mathematics and Statistics lessons. In today's video, I shall be talking about real numbers in terms of what they are. So the question we want to answer is, what are real numbers? Okay, so in our previous videos, we've talked about number systems such as the natural number system, the integer number system, the rational number system, and the irrational number system. So far we've discussed those four systems, and I want you to watch those videos again and again so as to understand what I'll be doing in this video called real numbers. In particular, what are real numbers? Now, I want to say a very big thank you to all of you who have subscribed to this channel, students across the globe subscribing to this channel. I want to say a very big thank you for watching our videos. Thank you for viewing our videos. Thank you for your subscriptions to our channel. Thank you for your shares of our videos. We are very grateful. That being said, let us begin. So the question is, what are real numbers? I will start with saying real numbers are points on an infinite line called the real line or the number line. Okay, so one way to describe real numbers is to describe them as points on an infinite line we call the real line or the number line. So such a line looks like this. Such a line looks like this. It is a line that is partitioned into two by the number 0. Okay, and you now end up having 1, 2 down to infinity plus infinity, and you have -1, -2 down to minus infinity. Okay, so this line is called a real line. Now, it so happens that on this line there are so many points, infinite number of points, and each of these points represent what we call real numbers. Okay, so every number that is a real number can be found as points on this line that is infinite in nature, because to the left it goes to infinity, to the right it goes to infinity. That is negative and positive respectively. Okay, now, so that defines or gives a kind of definition to what we call real numbers, that they are points on an infinite line called the real line or the number line. That being said, another thing I want you to know is we use the symbol, this type of R, an R with a double stroke, or this type of R. Either of them are used to represent real numbers. So this or this represents real number system. Okay, so that's the second point I want you to take note of. Then the third point I want you to take note of is that because of the non-overlapping nature of the rational number system and the irrational number system. Remember, the rational number system was defined to be the set of all x such that x is equal to a over b, b is not equal to 0, and a and b are integers. Okay, and the irrational number system was defined as a set of all x such that x cannot be expressed as a over b even when b is not equal to 0 and a and b are integers. So take note, these two sets have nothing in common, but take note, on one hand, the natural number system is a subset of the integer number system, and the integer number system is also a subset of Q. So every system, starting from the smallest system, the natural number system we've known, are all contained in the rational number system. Now, unlike this case, the irrational number system is not a subset of any of these sets. Okay, so you cannot find the irrational number system as a subset of the rational number system. Neither can you find the natural number system. So the natural number system is not found in the irrational number system. The integers are not found in the irrational number system. The rational numbers are not found in the irrational number system. So this set here has nothing in common with this set. For that reason, put together, we define the real number system as the union. We define the real number system as the union of Q and the F. Okay, so when you unite the irrational number system with the rational number system, it gives you the real number system. Okay, that's another thing I want you to take note of. So one way to represent this, especially as it concerns this number line, is that R is a set, therefore, that moves from minus, that contains from minus infinity to infinity all the numbers that are either rational or irrational. So let us go over it again. Number one, real numbers are points on an infinite line called, and on an infinite line called the real line or the number line. Again, real numbers are points on an infinite line called the real line or the number line. For that reason, it means that you can actually visualize that statement as this: a straight line that comes from minus infinity down to 0 and also from plus infinity down to 0 as a midpoint, such that all the numbers from 0 to the left are negative, all the numbers from 0 to the right are positive, and every point on this infinite line corresponds to a particular number, be it a natural number, an integer, a rational number, or an irrational number. So that being said, what symbol represents the real number system? It is either you are using this type of R or you are using this type of R to represent the real number system. Now, take note again, real numbers are made up of the union of two sets. If you unite the rational number system with the irrational number system, it will give you the real number system. So for that reason, you can actually write the real number system as one containing numbers from minus infinity to plus infinity, numbers that are natural, integers, rational, or irrational. Okay, now that being said, the next thing I want to consider in this video are the properties of real numbers. So, properties of real numbers. Properties of real numbers. So, what properties are there? I'm going to be explaining each of those properties of real numbers. Some of them, not all of them although. So, I'm going to be explaining them in this video. So, let's start with the first one I want to explain. So, the first property I want to explain is the property called trichotomy. So, it is called the trichotomy property. Now, what does this property mean or say? Now, this property is simple. The property says that if a number you pick, if you have a number x, such that that number is a real number, then what it means is that any of three possibilities is possible for x. If x is a real number, then x is positive, x is equal to 0, or x is negative. So if a number is a real number, then that number could be positive, that number could be 0, or that number could be negative. So this property of real numbers is called the trichotomy property. It tells you that immediately you tell someone that a number is a real number, it means that number is either positive, negative, or 0. Those are the three options available for a real number. Now, that brings me to the second property. So the second property is called the transitivity property. The transitivity property. The transitivity property. Now, what does the transitivity property say? If x, y, and z are real numbers, if x, y, and z are real numbers, then, according to the transitivity property, if in particular, then if x is less than y and y is less than z, then what it means is that x automatically is less than z. So look at the transitivity property clearly if you give it an illustration. So let's say 2, 3, and 5 are three numbers that are selected from R. 2 is less than 3 and 3 is less than 5. Implies that 2 automatically is less than 5. This property is called the property of transitivity. That brings me to property number 3. So for property number 3, what property do I want to talk about? Property number 3 is called the Archimedean property. Okay, so property number 3 is the Archimedean property. Archimedean property. Now, what does the Archimedean property talk about? The property assumes that if A, an element A or X, whichever one, so if X is a member of R, okay, then there exists, that is, that symbol means there exists an integer, then there exists an integer n, okay, that is, there exists an n that is a member of the integer number system, the positive integer number system in particular. Okay, so if X is a member of R, then there exists an integer, a positive integer, such that X is a member, such that X is a member of R now implies that that n is greater than X. Okay, what the property is saying is that any number at all you pick, according to the Archimedean property, any number at all that you pick from the real number system has a corresponding integer, a corresponding positive integer that is greater than it. Okay, so if you pick any number that is a real number, then there is a corresponding positive integer that is greater than that number you've picked as a real number. Let me explain this. Okay, now let me explain this using an example. So if you look at this, you will come to realize this. So let's see. Now look at it carefully. You will notice this, that if I select 3 as a real number, then it is possible that, on the other hand, in this case, my 3 is my X. Okay, so if I select an X3 from the real number system, then it is possible to select an n. Let me call an n 5. It is possible to select a 5, which is a member of Z plus. Take note, Z plus is the set of all positive integers. So it is possible to select an n from Z plus such that n is greater than X, in which case 5 is greater than 3. So it is always possible for any real number you pick to select an integer, a positive integer that is greater than that real number. That is what the Archimedean property is talking about. Now, the next property I'll be discussing is the density property. The density property. Now, density describes a saturation. You can call it a saturation property if you don't want to call it density property. So, density describes a saturation of an interval in this case. Now, what does it mean? It means that if you select X and Y as members of the real number system, then according to the density property, if X is less than Y, then X is less than Y implies that there exists, again, I'm using that symbol, there exists an X that is also, it means that there exists a number, let's call this one Z. There exists a Z that is a member of the rational number system, such that you can find that Z in between X and Y. So the density property tells you that in between any two real numbers, there is always a third number. Or there is always a saturation of numbers, okay? Not just one. So in between any two real numbers lies an infinite number of numbers, okay? So if you have x and y as two real numbers selected from the real number system, take note, in between x and y, if x is less than y, there are so many real numbers found in between, or so many rational numbers found in between. So you can actually prove that property. Clearly, if you want to prove this property, then note that if x is less than y, then what it means is that x plus itself is surely less than x plus y, and is surely less than y plus itself. And that means that this is true. That means that x plus x, which gives you 2x, will be less than x plus y, and which in turn will be less than y plus itself, which gives you 2y. Now, if you divide through by 2, if you divide through by 2 in this inequality, divide through by 2, you end up having 2x over 2 is less than x plus y over 2 is less than 2y over 2. Now, if you bring the continuation here, you end up having that when 2 cancels 2, you end up having x is less than x plus y over 2 is less than y. Okay? And that tells you that if we use x plus y over 2 to represent z, it shows you that that density property is, after all, true, because it now means that in between x and y, there is a z, which is equal to x plus y divided by 2. But if you generalize this property, the property is actually telling you that in between two numbers you select from the real number system, there is a saturation, a dense interval containing numbers that are from the rational. There is a dense interval of numbers. So that being said, let us now go to the next number system, the next property I want to discuss. Okay, so let's go to the next number, the next property on real numbers I want to discuss. So let's look at another property. Now, for the next property, let's see. According to this property, if you have x and y, x, y, and z being members of R, okay, the real number system, such that x is less than y and z is positive, then it follows that multiplying x by z will remain less than multiplying y by z. Okay, so that is what this property is saying. Okay, so the property is saying that if you use a positive number, such as z, okay, if you use a positive number such as z to multiply two other numbers, one less than the other one, that are selected from R, then using x to multiply z will still give you a result that is less than using y to multiply z. Okay, so for instance, let's assume that I pick three numbers, 3, 4, and 8, that are members of the real number system. Now, if you pick 3, 4, and 8 that are members of the real number system, then you realize that 3 times 8 will remain less than 4 times 8. That is because 3 times 8 will give you 24, and 24 is less than 32, which is 4 times 8. So that is what this property is talking about. Now, the same property talks about another version of itself. Okay, if it so happens that x is less than y, but this time around z is negative, then the property is telling you that x times z will no more be less than y times z, rather it will be greater than y times z. Now let us look at it again. So let's maintain 3 and 4 as our x and y, but let us choose a z that is negative. Let's say -2. Okay? All from the real number system. So if we select 3, 4, and -2 such that this 3 is your x, this 4 is your y, and this -2 is your z, then what it means is this. It means that 3 times your z, which is -2, on one hand, will be greater than 4 times your z, which is -2. Now look at it carefully. You will notice that 3 times -2 gives you -6, which is greater than 4 times -2, which gives you -8, and -6 is greater than -8, and that confirms that property to be true. Now, if you look at it again, let us go to the next property. The next property I want us to look at is this one. If A is a member of R, or if X, I want to be consistent with using X. So if X is a member of R, such that X is positive, then it follows that 1 over X will be positive. And look at it from this angle. So you pick 3 as a member of R. If you pick 3 as a member of R, note that 3 is greater than 0 because 3 is positive. Now, 1 over 3 will still be greater than 0. That is what that property is saying. Okay? So if you select a number from the real number system, and that number is positive, 1 over that number will remain positive. 1 over that number will remain positive. Now, what if you select a number x from the real number system such that x is negative? The same property is saying then 1 over x will still be negative. And again, if you look at it from this angle, select a number say -1 or -4 from R, from the real number system. Now clearly -4 is less than 0. If you look at it very well, you will discover that 1 over -4 is also less than 0. That is what that property is saying. Now let's go to another property of the real number system. Another property of the real number system talks about this. Okay? So if x and y are members of R, such that you have x less than y, okay, and it so happens that x is positive and y is positive, then this property is saying that 1 over x, because x is less than y, will be greater than 1 over y. So let us see. So if you pick 2 elements at random, or 2 numbers at random from the real number system, such that the first one you pick is less than the second one, and both of them are positive, then 1 over the first one will be greater than 1 over the second one. Now let's see that. Now, as an example, I'm going to show you an example. Let's assume that we pick 2 and 4 from R. So I'm picking 2 and 4 from R. If you pick 2 and 4 from R, notice one thing, that 2 is greater than 0 and 4 is greater than 0. Notice again that 2 is less than 4. And because 2 is greater than 0 and 4 is greater than 0 and 2 is less than 4, notice that 1 over 2 is greater than 1 over 4. Because 1 over 2 is half, 0.5, which is greater than 1 over 4, which is 0.25. Okay? So that property is true. Now, let's go to the next property on real numbers. So, the next property on real numbers I want to show you is this. If x and y are members of R and x is less than y, take note, this implies this would only happen if and only if you have y minus a, or y minus x rather, is greater than 0. So it is simple. Okay, if x and y are members of R and x is less than y, then it implies that y minus x is greater than 0. Look at it critically again. If you select 2 and 4 that are members of R and 2 is less than 4, what does it mean? It means that 4 minus 2 will be greater than 0, and that property is true. Again, if you select 1 and 3 that are members of R such that 1 is clearly less than 3, notice that 3 minus 1 will be equal to 2, which is greater than 0. So that property is true. Now, let's go to the next property I want to discuss. If x, y, and z are members of R, and in particular x is less than y, then it implies that if x is less than y, it implies that x plus z will be less than y plus z. So if you add z to x and you add the same z to y, when we know very well that x is less than y, then x plus z will still remain less than y plus z. So let's check it out. So I'm selecting 1, 2, and 4 from R. If you select 1, 2, and 4 from R such that 1 represents your x, 2 represents your y, and 4 represents your z, take note of the fact that 1 is less than 2, clearly. But if you look at it again, you will notice that 1 plus z, which is 1 plus 4, is still less than 2 plus 4. Because 1 plus 4 will give you 5, which is less than 2 plus 4, which gives you 6. Okay? So that property is true. Okay? That property is true. Now, the last property I'm going to be looking at in this video on real numbers. I haven't told you what real numbers are and what some of the properties are for real numbers. Let us conclude this video with a last property. This is not to say that all the properties are what we have discussed. There are so many other properties we have not discussed. So this property says if x, y are members of R with x being positive and y being positive, then for any, if it happens that you select any number n that is a natural number, if you select any natural number n, then x is less than y implies that x raised to power n will also be less than y raised to power n. So the property is true. If you select 2, 5, and 9 that are members of R, select any 3 of them and notice what happens. Notice that provided your 2 is your x, your y is your 5. Let me omit the 9 here. If you select 9 from the natural number system, of course 9 is a natural number, then you end up realizing that 5, which is your y, and x, which is your 2, or 2, which is your x, would imply that x is less than y implies that 2 is less than 5. And by that property, it follows that 2 raised to power 9 is less than 5 raised to power 9, clearly. Because if x is less than y, then x raised to power n is less than y raised to power n. And what is n? N is any natural number. So that property is true. That being said, please, thank you very much. This brings us to the end of our discussion on real numbers, where we had looked at natural numbers, we had looked at integers, we had looked at rational numbers, irrational numbers, and finally summarized with real numbers, what they are, and the properties of real numbers. So the next video we'll be looking at is to start discussing modulus of a number, and also we shall be discussing complex numbers and the Eigen diagram. We shall discuss complex numbers in subsequent videos, the Eigen diagram, and the modulus of a number. Thank you very much for watching this video. Thank you very much for subscribing to the channel. Thank you for your likes and your views, your watch hours. Thank you very much.